Cool. Okay, so thank you very much. Thank you for your patience for these AV problems. Unfortunately, they seem to happen every now and then with this video text. Sorry about it. So, PowerShell and Azure DevOps, the two bodies of DevOps. Unfortunately, the title changed a little bit because Microsoft decided to rename the product from VSTS to Azure DevOps, so it doesn't sound as catchy as it used to. But I'm Matteo. I work at One Identity as a systems engineering advisor, but I'm also Microsoft MVP for developer technologies. PSM1. Feel free to pester me anytime, email, Twitter, blog. I'm always happy when I get questions or anything. So, I'm only a PowerShell user, and the reason behind this session, after the brilliant keynote from Richard earlier this morning, the reason for this session is because being a PowerShell user means that I only consume it as a tool, and over time, I use it more and more. I mean, it's one of my main tools I use on a daily basis. And I realized that there is so much value in integrating PowerShell scripts and PowerShell itself with Azure DevOps. So I collected together a few examples of where are the most valuable points for me, and I wanted to share them out. So I'm not a PowerShell expert, not even close to you, but I'm an Azure DevOps expert, and I use PowerShell on a daily basis. So that's the idea behind the session. Just to have an idea about you, how many of you use Azure DevOps or TFS or VSTS? Okay, cool, 60% of the room. How many of you use this stack with PowerShell as a first-class citizen? Okay, so there is some value in this session after all. So why am I here? I'm here because I'm not going to talk about Pesta, for example, because I know that Pesta can be used to test PowerShell scripts, and I do it as well, but it's not the content of this session. I'm just here to talk about the different perspective, which is from a person who is very deep into DevOps, where PowerShell is bringing benefits to me. And that's the idea of my perspective. So what I'm not going to show you today is how to interact with TFS or Azure DevOps via VSTM or TFS commandlets, for example. Those two are libraries. The first one from Donovan Brown of the League of Extraordinary Cloud Developer Evangelists, or something like that. Anyway, it's a brilliant library to interact with Azure DevOps and TFS as well, to create, for example, team projects, to provision, build agents, stuff like that, build pools, stuff like that. TFS Commandlets is an open source project from a fellow MVP, and it's very, very handy where you need to interact with the stack inside the project, okay? So, quick example, if you need to create areas and iterations from PowerShell, you use that. It's very easy, it's very straightforward, and it works extremely well. I'm not going to show you how to consume REST APIs from Azure DevOps for automation, because it's all covered in the docs, and it's down to the actual use case you might have, what you want to automate and why you want to automate. So there is little point in showing you how to use an HTTP client to consume REST APIs. It's stuff you'll find on Google, basically. And neither I'm going to show you how to deploy infrastructure via ARM, because I assume that you as PowerShell power users, you might know this better. And anyway, it's extremely simple. I'm not going to show you how to use a version control system, either Git or TFVC, but I'm going to mention it fairly often. So do you use a version control system for your PowerShell scripts? Please raise your hands if you do. Okay, good. And I'm not going to talk about best practices, because, I mean, the keynote this morning from Richard was really enlightening about best practices. And the point that Ryan made about best practices that are valid just in a point in time, it's very true. I don't care if my PowerShell scripts are not very nice to read, but they do what they are supposed to. They are documented, so it's good enough for me, okay? Because I'm not a PowerShell developer. I do something else entirely. So to me, talking about best practices in this context feels of little value. Instead, I'm going to talk about other things that are reusable, okay? That are more like, not really patterns, but situations where you can leverage on your PowerShell knowledge and Azure DevOps or TFS. So those two together, what do you mean? Because I said that I'm not a developer, I'm not a PowerShell developer. I said that I'm not going to use REST APIs for automation. I said I'm not going to use third-party libraries for interacting with the system. What do I mean by the two best buddies of DevOps? Well, we know that PowerShell is an extremely powerful tool. Okay, you can do pretty much anything with it. You have access to the .NET framework as well. So there is a ridiculous amount of things that you can do with it. Automation, as we know, is one of the pillars of DevOps. Okay? One of the first things that you learn is that you should automate as much as possible. And PowerShell, of course, comes in very handy with this requirement. Also, Azure DevOps is an integrated stack. It used to be called VSTS and then other names even back in the past, but it's an integrated stack that offers you so many services, from repositories, so Git or TFVC, to build pipelines, to work item tracking. So integrating a stack, and not just a tool, with an automation DSL, if you want, or anyway, an automation language, something that's so powerful as PowerShell, provides you, in certain situations, lots of value. At least, that's my opinion. Some examples of the most basic interactions you can have between PowerShell and Azure DevOps, but very valuable as well, is that you get the full power of PowerShell wherever you're running your tasks. So you trigger a build, the build runs on either an agent or a so-called deployment group, which is just a container for target environments, virtual machines or whatever. Once you run something within one of those two contexts, then you can literally access anything with it, because you're running on potentially a Windows Server machine. Okay? So if I run something on a build agent, which is going to compile my code, deploy my stuff somewhere and things like that, it's not black magic. I have access to a proper server or a container, depending on the situation, but still, I have access to an operating system, and I have access to it via PowerShell. Infrastructure as code with DSC or Azure Resource Manager, I mean, this is extremely powerful. Infrastructure as code done that way, it's brilliant. Also, reusable tasks. It's normal within a company to develop some sort of libraries, some sort of set of scripts that you can reuse. Those can be redistributed both internally as a developer team artifact or as a consumable artifact for maybe power users. So if you have your own libraries that have nothing to do with TFS or with Azure DevOps, and you want to distribute them within the company, you can do that. And it gets very handy when you need to maybe provide tools for support, for example, scripts for support. There is little point in providing a file share that has all its pros and cons, while instead you can actually have a feed that's going to provide you those libraries. And then have a CI/CD pipeline for your libraries. So you're in the DevOps track, and I assume you're very familiar with CI/CD, right? Right? I see nodding, but okay. So, like we will see later on, there is nothing that stops you from using the same concepts from a CI/CD pipeline. The same concepts that you use for your application code, for your system that you want to deploy, for PowerShell libraries. Because at the end of the day, to me, they're just yet more code. So you can use the same concepts, the same tools. Let's start with this. Scripts are first-class citizens in Azure DevOps, okay? Because it's code. And being Azure DevOps a stack which contains code, deploys code, and tracks code, of course, it means that it's first-class citizen. And you can reuse everything you have, both in terms of scripts and tasks, which we will see later on what it means, inside your pipelines. So if your colleagues from the building in front of you is going to develop this fantastic set of scripts for deploying the line of business application that you've been working on for the last 6 to 9 months, and he does a brilliant job at it because he's a very good PowerShell developer, and you would like to leverage on them and reuse them, you don't have to go to him or send him an email and say, look, can you share your scripts? Could you please explain me how they work, how do they work, or stuff like that. You can actually just reuse them as they are, like if they are inside an out-of-the-box package. And you have possibilities of having, for example, a consistent behavior for free. So you have a set of scripts, you encapsulate them into a group, and then you recycle it. Or you can leverage, of course, on variables, and you just integrate it within the stack. something that I really hate is when a script comes out with exit code 1. So it doesn't make sense to me, not because I'm not a power user for PowerShell, but because it's not verbose enough. If I want some sort of dialogue, well, not dialogue, but some sort of meaningful messages coming from my scripts, they need to be integrated in the stack. And it's extremely easy to do this. So let's take a look. I will try to, the session itself is going to be on fairly basic examples, at least at the beginning. And if you have any questions, feel free to stop me. I know that I'm the only thing between you and lunch, so I will try to be as quick as possible and as concise as possible here. But if you have any doubt or anything doesn't come up straight, let me know. So, first example I mentioned is about pipelines. Okay, so that's where most of your PowerShell activities can be reused. So, system interaction. You see, this is, for example, that's a partially failed or partially succeeded build. So what am I going to do? Well, nothing too fancy, to be fair, because once you deal with PowerShell, you see that you have an execution context. In this case, is the agent. So it could be your on-premise build server, or it could be the Microsoft hosted one in the cloud. Regardless, you have a session over there, so you can do many things. In my example, of course, I'm using write host, because that's the most simple example you can't do. And this is an inline path, which means that you have only like 500 characters or something like that.
Excuse me, any chance you could zoom in a bit?
Yes, of course.
Thank you.
Is that enough?
Yeah.
Fantastic. So, of course, that's a basic example here, but you don't have to use it. Because in a real world, what you would do is to provide a file path. So you store your scripts in the version control system, the build process is going to pick them up from the version control system, and then you will have them at your disposal. But in my example, again, I don't need them because I just want to show you that you can actually execute PowerShell stuff. So what will happen in this case, that's a very simple build. I will trigger it. The build goes on, it does some things, and it's fine. But this is, that's level 0, okay? Not even level 1, this is level 0. You can just see that you can do things with it. In the meantime that the build completes, I will show you something else. It takes, of course, a few minutes because I'm using the cloud-hosted build, which means that a new VM is spun every time for security reasons, and then you download stuff. It takes like 2 or 3 minutes in this case because it's a fresh one. What you can do, for example, here, this build will fail, okay? And that's accounted for. But what you can do is to combine, for example, multiple scripts, and then you can make them a task group. A task group is a way of combining together some activities in Azure DevOps or TFS so that they can be reshared across different projects, different teams, okay? So this is just about writing 2 things on the logs, and of course it doesn't make any sense to group them together. But think of it as a number of scripts that run together all the time, like any kind of plumbing operation you would do before deploying or before updating some sort of virtual machine or some sort of services. All of us have them. Instead of having 5 or 6 steps that are going to be always the same, why not grouping them together? And say, okay, this is my PS Day group. It's going to be just for build, but it could be for any other category, all right? So in this case, it's for build. That's it. Done. What's going to happen is that whoever wants to use it can leverage on this actual task instead of having multiple activities. Now, a group, being a set of activities, contains those activities, but you also have the possibilities of adding more from here, and that's where you get access to other PowerShell scripts. PowerShell tasks are this. Those are the 5 out-of-the-box ones. And this is PowerShell, plain PowerShell, fine. You have Azure PowerShell if you need to interact with Azure, so you get all the commandlets preloaded. But then you also have PowerShell target machine. If you're targeting a deployment group, so you're doing stuff on virtual machines, for example, physical VMs, you get access to the actual machines. Let's say this, for example. So what are the machines I'm interested in? Login and password, those can be secrets, of course. They shouldn't be in plain text. HTTP or HTTPS, and then what script to run, and all sorts of things, okay? So that's where you interact with an actual physical machine. And it's very powerful because something is, for a PowerShell professional, having to deal with a script, and it's very good. But if you're a user like myself, you want to have as little interaction as possible with the script proper, especially if some third party created it, right? So if I have this kind of interaction, that's much better for me. And also, you should have the possibility of seeing, yeah, you will see where it's used. So you become the owner, potentially, of this group of tasks. And you can see where it's used. So you can go to someone and say, oh, look, I see that you're using this set of tasks. There's going to be a breaking change, or is there anything that you would like to see change in that? Because it's yet another task at the end of the day, right? So if I go here in the build, I'm not going to save it anyway. Of course, the build failed because it's the last one that I triggered, and as you can see, exited with code 1. This doesn't make any sense to me. I know there's an error, fine, but why? So what I can't do, first of all, is to reuse that task group that I mentioned before. So here, should have PSD group. So I can add this as a task, like I would with any other PowerShell task or build task, and I get the same behavior. But in this case, what I'm interested in is not this, of course, but is to integrate my logging with the stack. I don't care about having exit code 1. It's useless. So what I will do, sorry, is to disable this and run a new build with these other tasks. It's the same sort of thing. It's right host again, but I'm going to save and trigger this for a moment. So same concept, same idea, it's still right host, but I'm using this double hash VSO and then task.log issue type warning for a warning, and same stuff for an error. That's it. So doing this means that in my build, I'm not going to get exit code 1 anymore, because again, it's a little value. But I will get this. This is an Azure DevOps error. And the warning as well. I will get that this is an Azure DevOps warning. Now, if I'm an operator, I don't care that much. I set it up as to continue on failure. But I don't care as much. But if I look at the summary, instead of exit code 1, I will get this. Okay? And this is where the value is. Because with just that different way of typing the error code or the warning code, then you get a first-class interaction and a first-class integration. This, to users, to consumers, it's brilliant. Because I don't care that it's going to be a PowerShell script. I don't care what's inside. I know that the script does a certain number of activities, and I get the result here in the log or in the summary. So that's where I feel it's extremely powerful, because this is much better than, for example, the other one, the 880 build, which, yeah, get exit code 1 here, and in the summary, just go, yeah, PowerShell exited with code 1. Okay, fine, and so what? I might not be involved with who created the script, or it can come from another part of a company, and I might not even know about PowerShell, because I might just get this from a different team, say, look, this is the build, it's going to create some artifacts, those artifacts will then do things, and I don't care about the build because I might not be even interested in it. I just want to get the artifacts. So getting exit code 1 doesn't help. And I know that I keep banging on it, but I saw the change when, in different situations and different circumstances, I managed to make people switch from this kind of error and interaction to the other one. And the perceived value in terms of integration is great, because then you know, oh yeah, you know what, you can integrate it into all of our scripts that run into a build pipeline so that people can actually understand what's going on, and you can then write verbose warnings, for example. If you are running it on a proper VM and not maybe on a build agent, they can say, look, you're using a certain version of PowerShell, it might be deprecated soon, or stuff like that. Or your commandlets might be deprecated soon, things like that. And yeah, you can redirect the warning just by adding the log issue. And it's as easy as that, but it provides huge value for the end user. Same applies, of course, to Azure PowerShell, Azure Service Fabric. Wherever there is PowerShell interaction, then you get this power inside Azure DevOps. Any question? I know it's fairly basic, but if you think that in perspective, it gives you a big deal of way of interacting with both the system and the users. So I felt that it was hugely valuable, at least it was for me. Now, yeah, it is extremely valuable. What we know also is that if you have the possibility of running PowerShell scripts on your target context, on your execution context, you can easily perform all the advanced deployment patterns you read around. Do you do rolling deployments, blue-green deployments, shadow deployments, these sort of things? Okay. If you don't, and you're scared of it, because I've heard that as well in the past, it's nothing that you can't do because it's too complicated. It just takes a little bit of automation, and of course, not just in the cloud, because everything applies to on-premise as well. So this is an example of rolling deployment, very basic, bare to the minimum. But I have a production cluster swap, which means that I'm targeting a different cluster instead of, from the blue one, sorry, I'm targeting the green one. Then I'm running stuff on the blue cluster to update it. I'm going to warm it up. Once it's ready and tested, I can switch it over again. And this is what I'm going to do, okay? This is on-premise. So I run my script with username and password as a secret. So I don't care about what is it because it's been set into the pipeline. And I mean, this is the script. It's a 27-line script that plays with DNS. And you know better than me that it can be done much better. It could be done however you want, okay? But all it does is to swap the DNS record for what's the production cluster. And it acts as a load, it could be a load balancer, okay? I'm simulating a load balancer here. But the idea is that this kind of scripts, as simple as they are, integrated into a pipeline like this, can be hugely valuable. Because this, as you see, this is running on an agent, okay, the swap production cluster. It means that it's outside of the execution environment of your target servers. Once you do that, and you're acting on the load balancer, basically, it could be a load balancer. Then on the deployment group, which means on the actual machines, you would do everything you need. Stop the NLB node, drain the connections, then stop IIS, deploy the package, restart IIS, restart the NLB node. You warm it up with a script. It's all things that you do in PowerShell. And it's, I mean, it's no rocket science. This is pretty much everything you get out of the box. This is the warm-up script. Again, extremely simple. I check that my target environment is live. If I get a 200 code in response, it means that everything is okay, so it's okay. Otherwise, it stops and I get an error. Fine. You see, if I get the error, if I get an exception, I treat it as an error and it failed the warm-up. So the build fails and everything is stopped. Makes sense, right? And that's all you need to do to integrate it with the system. So this is the very basic. This is the prerequisite you may need to start getting some value out of it. But Azure DevOps is an extensible stack. There is a marketplace out there, okay? And you're not even forced to use the marketplace if you want to redistribute your own extensions. So this extensibility model allows you to create an ecosystem. And that's very, very important. If you are a company the size more than one, it's important to have an extensibility model and to consume extensions. PowerShell is literally one of the technologies at its core, okay? Things are moving towards .NET Core. Things are moving towards JavaScript and TypeScript, actually, for cross-platform compatibility. And I'm not going to touch that. But if you have a set of tasks or a set of scripts that you want to package and reuse, you can do so in 5 minutes, okay? Because the impact you can have with customization, you can guess where this is going to be in the release. You can customize pretty much everything in Azure DevOps or TFS. But the most impact you get is on build and release because, yeah, you can add customization to the work items, you can add customizations to the repositories, but where for PowerShell you get 100% control over it is on build and release. So how is it made? You build a scaffolding with a tool called TFX, which is the command line tool for creating these extensions. You add your scripts, then you edit the manifest, you add an icon if you want. You download the PowerShell SDK for extensions. You repackage it, you publish it to your server, to your target server or your target Azure DevOps organization, and you're done. If you want to leverage on the public marketplace, then you can publish this extension. Now, how is it made? Let's create one from scratch. I mean, it's easier. PS Day. So create a new folder, went in there, then TFX, build, tasks, create. Yes, I have the list of commands here because I have a very bad memory, so no problem about it. I'll give it a name.
You might have to make it a little bit bigger.
Bigger again? Oh, yes. Thank you. Right, so is it font? Let's make it a 20. Should be right on the bottom, isn't it? Isn't it? Cool. So PSD task. PSD task again. Task description. Task author. So, oh yeah, you're right. It is absolutely right. You can't use spaces. Okay, so I created my task. The task itself is this. This is the content of your task, okay? An icon, a manifest, a JavaScript file, or a PowerShell file. That's it. What I need to do here is to open the manifest, which is the task.json file. And just because I know that I'm not targeting cross-platform environments, I'm going to take off the Node.js execution entry point. Just because I know that I'm not going to use it in this case because I'm recycling other things. So I know I'm not going to use it. Fine, I'm going to take it off. As you can see, I can define where the task is going to be used. Let's see if I can zoom it a little bit. Yes. So I can see, OK, this is a build and release task. And I will show it in both hubs. It could be just a build task or a release task, right? The script itself, which again, it's an example, but the script itself is this. And all you need to do, in this case, is to just reuse this invocation context, as I call it. It's the Azure DevOps execution context. You can get the input, and you can get all the parameters that go through. In this case, it just writes something, okay? But it doesn't do anything. But here, you can enter whatever script you want, or you can add those scripts, and then in the manifest, get in there and say, okay, what I'm interested in is this file. In this case, it's just sample.ps1. That's all I'm interested in. Then, as I said, I need to install the SDK. So the SDK is a name. That's where the nodes come in handy. VSTS task SDK path. Now there is a catch here. If you just save the SDK as it is, it's not going to work. That's because the agent expects this SDK in a specific location. So what I will do is to get this. This folder is going away. And this folder is going to go into the ps_modules folder. This is where the build agent expects the SDK to be, okay? It is foolproof, but it needs to be that way, right? Otherwise, it's not going to work. I have all builds showing that, if you want. So literally exactly the same task, but like that. Once this is done, I'm done in terms of creating the task, because I'm reusing the scripts I need, and I'm doing what I need to do to publish it. So we log in to my instance, which in this case is an Azure DevOps organization. Or if you're wondering, it's Acme Corporation because of the Looney Tunes. Okay, and I use a personal access token, of course. Oh, come on. Really? Okay, fine. Once I'm logged in, I can actually push stuff. So in this case, it's tfx build tasks upload task.path should be .share. Is it the right path? That's it. I'm done. So remember what was it called? PS task day? PS day or PS day tasks? If I go into my build, so even the same one, I don't care. And here I'm going to disable this too. And I will add. Oh, that's because it's not very refreshed. Yeah. My bad. Okay, that's it. Don't mess around with it. Right, so to me, as a user, as a consumer, this task is nothing more than an out-of-the-box task. You see that I have no control over the script. I only have control over the message. This script is just printing a message, okay? I will save it and queue it, and that will be it for this one at least. This is a step forward compared to what we did before. Because before we just packaged together a set of scripts, which is fine, but it's hardly maintainable, I would say, in a large scale. Because then you need to deal with all the instances where it's referenced and stuff like that. In this case, you control the versioning of your script, which means that if you change something, users will get this drop-down updated with different versions, for example, and then you can set deprecation, and you can deal with, say, okay, look, this is version 0 dot something, then in version 1 you'll get the full version. Then you might get version 2 preview, and the default version you will use will be version 1 because it's the stable one. But if you want to try version 2 preview, then you can select it into the drop-down and go there. Or if you're deprecating a task, then you can say here, if you get version 0 dot something, a nice message saying, look, this task is going to be deprecated. Stuff like that. It's better because you're controlling the distribution. Instead, if the task group is there, you can update it, but you need to handle all the communication manually. The user interaction is manual in that case. Right? So let's take a look at the build. All good. And in the logs, I was not joking, it literally writes hello world. So yeah, that's what you need to do, okay, if you want to recycle a script. In this case, my script is the most basic ever, but I'm not a PowerShell power user, so that's where you get in there, and then you can customize it. If you love this approach, there is a marketplace. And if I recall the correct URL, that's it. Here, you can look for the Azure DevOps extensions, and you can your extension could show up here. So if you want to distribute your extension to the public instead of keeping it internally, you can do that. And yeah, you can have paid extensions, you can have free extensions. It's a full-fledged marketplace. Right? Any question about it? Tell me.
Can you schedule a task?
Can I try this? So I would like to throw these out to you.
Yeah, sure.
Cheers.
Can you schedule tasks to run within the, yeah?
The only thing you can't schedule is, well, I mean, tasks to run, yes, but you can only schedule them inside the execution context. So you need to have a build that it's running, okay?
Okay.
So there is little sense in scheduling them. You can't do it because it's still PowerShell. So you can write into the scheduler, for example, on a Windows VM, you can use the task to write something into the scheduler, and then the task is going to run independently from the pipeline.
Okay. But you couldn't run it, you couldn't, for instance, put in like a trigger off an event to initiate the build or something?
Oh yes, you can do that, but that's this is one of the features of a CI server, okay? So it's not related to the script. A build can be triggered in so many different ways. So you can have a scheduled build, you can have a continuous integration build. This is a normal feature of a continuous integration server, okay? So if you have a change in the repository that's linked to the build, then the build is going to run automatically. Otherwise, you can schedule it for, I don't know, Sunday morning at 2 o'clock in the morning, okay? You can do that, of course, but that's not related to PowerShell. It's not related to the script. It's related to the fact that you're effectively using a CI/CD orchestrator.
Yeah.
Okay. I hope it answered your question.
Yeah.
I'm sorry, I misunderstood it first time. Any other question? Tell me, Graham.
Matteo, suppose you've got, yeah, cheers. Suppose you've got
I can hear it.
several versions of your different tasks.
Yes.
Is it possible to force users to not use earlier versions?
No, you can't do that. You can only take down the versions you want, and if it's the marketplace, it's easier. Otherwise, it's even easier with TFX because you just delete it from the instance. But you can't force a user to not use a certain version. Because in the manifest, you see that in the manifest you have demands, and so you can say, okay, I can add a certain demand and say, okay, you can only use this, this, and that. You have a versioning here. You have the minimum agent version that you can also use to leverage this kind of situation. Because, for example, if you have a certain old, for example, TFS 2017 agent, then you can't do this, this, and that. So you can only use it in a certain context. Otherwise, you can't. It's flexible, but it's not that flexible because you still need to decide who can use what. Okay, so it's pretty much it in terms of what you can do. You can increment your tasks, but you can't just say, okay, yeah, it's deprecated, stop using it, and I will block you, right? I don't think it's feasible.
Can you also do conditioning on steps? Like if something fails, then skip the step?
Yes, 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 yes. The step itself, I mean, what I did was the most basic encapsulation of a script. But if you look at, for example, at the PowerShell, at the normal PowerShell task, you have control options. So you can say, okay, continue an error, fine, or enabled or disabled, fine. But you also get run tasks in certain conditions. Let me zoom it for you. So this runs pretty much all the time. As soon as you get to the step, it runs. Then this runs even if there is another condition, fine. Only if a previous task fails. So for example, it fails, okay, collect all the logs from all the parties involved and store them as artifacts, fine. Or custom conditions. With custom conditions, if we look at the docs, you can specify your own expression. So for example, those are examples of conditions. It's and equal to, stuff like that. So you define your own conditions with variables potentially, and then it runs under the set of conditions. Easy example in the development role, pull request. If you have a pull request going in, you can do this, this, and that. Otherwise, skip them all together because you're going on master. That's an example. You can.
Can you set
your custom tasks so that you make a change and then you get that task to build and deploy to wherever it's going to.
100%, yeah. You can just embed the calls to TFX or whatever that you do it. There are several blog posts from fellow MVPs that have done that. And actually thinking about it, there's going to be also a meetup about it next month on extensions. So if you happen to be around, we'll talk about that in detail.
Thanks.
Sorry. Is there a maximum timeout?
Yes. Yeah, you can set a timeout, of course.
Which is by default?
It is 0 by default, so it runs until it stops or until it timeouts at 10 minutes, I think.
10 minutes.
That's if I recall correctly, it's the default, but that's just because it's running on Azure in this case, so it can consume resources unnecessarily, and otherwise you can set your own timeout.
Cool, thank you.
Right. There is something more though. What we saw up to now, everything here was about PowerShell in a integration type of scenarios with Azure DevOps, right? But there is also another scenario that's very important to me. Do you embrace CI/CD, first of all, like I said before? Do you do that? I think if you're here, you do. So is there anything preventing you from doing the same things you do in a CI/CD pipeline to your libraries? No, the answer is no. You can use Azure repos, for example, to store and version your script code, so Git or TFVC. And then you can build with your pipeline, you can build your libraries, create Nugget packages as artifacts, and then store them into a feed that your users can consume. It means that gone are the days of file shares here and there with scripts, because you would use ps-get. So you distribute it. And if you can do it for an application, why can't you do it for a script, for a library? I've heard this thing in the past. Oh yeah, we do it for our application code, for our systems, fine. But yeah, we don't do it for PowerShell scripts. We just store them on a file share somewhere. There is no point. It is still code. So yeah, you can quickly create an end-to-end pipeline. I'm going to skip through the slides. But you can also control its distribution and its life cycle because it's a Nugget package. It's a feed. So you control, like nugget.org, you control it as such on your own. So let's take a look at how to create a CI/CD pipeline for PowerShell libraries. Again, library, it's the most simple library in the world because I just wanted to show you that you can do it. No, not that one. So my library itself is, let's do this actually. Okay, so I'm inside my Git repository now, and here I can open the whole folder, Visual Studio Code. So my actual library does nothing more than writing down what's the timestamp, okay? So I do get date and I write it down. That's all I do, right? In order to make this, you know that very well, an actual function that can be redistributed, you need to create a manifest. And up to now, we're there, okay? We're nothing too strange for you. Right. What we want to do is to leverage on Nugget. So the first thing I will do is to create a NUSPEC file. I'm going to skip through how to do that, but all you need to do is to download nugget.exe, which is this thing here, and use one of these switches to create the manifest. Inside the manifest, which is, it's nothing more than an XML file, okay? Inside this manifest, what you will create is typical information like version, authors, license, whatever. This is used by a command called nugget pack. Everything is very nice once you're on your own machine, but there is little point of doing it locally because you want to centralize these activities. Okay, you don't do everything on your machine. It works on your machine, then you ship it somewhere, and it doesn't work for anybody else. Okay. So my idea here was, why not we treat this exactly like any other application code? And so in Azure DevOps, let me zoom out for a second. In Azure DevOps, I created a repository, which, as you see, are you familiar with PowerShell Get? And are you familiar with PoshGit, this thing here? Okay, so I created this code repository where I put everything in there, and everything is versioned, because as you can see, yeah, let's leave it. As you can see in a second, this is not the right one, but it's this one. Okay. So everything is stored here. There is a revision history, so it's like proper code. Okay, it's like proper application code. Here, the natural thing for me that I work in ALM and DevOps since pretty much the Ice Age is to create a build. My build here will download the tools required to create my package. Okay, so Nugget 4.3.0 at the moment, and this is an out-of-the-box tool. Okay, you just add it here with no special commands, but it's literally just the default. And then I run Nugget pack. Nugget pack picks up the content of a folder and the NASPEC manifest and creates the package. Okay. Once this is done, you see you have all sorts of options. You can have automatic versioning, but you need to work a little bit on it. So in this case, I left it off. You can also use semantic versioning if you like, right? Once I did that, I will upload my artifacts to an artifact storage, right? So what I will get in this case, I'm going to skip fairly quickly here. So now library, and I will get the actual build. So what I get here in terms of artifacts is a Nugget package. Now, very nice again, but there is no distribution model here. This is just an artifact, right? What I need to do is to link this to an artifact repository, which is a Nugget feed. Okay. So what I did was creating a new one and push my library here. Once it's there, it's exactly like a marketplace if you want. Okay, it's a feed where you can control what's shared, how it's updated and stuff. But in my example, okay, how is it called? Register. Actually. So what I did was creating this small script. Now, this is an authenticated feed, of course. So you need to authenticate against Azure DevOps, and it's fine. I will always use these 4 lines here to authenticate. It might not be the best practice, again, but in this case, it's for internal consumption. And I will register this Nugget feed with my profile. Okay. So actually, I'm going to use the ISC. I think it's better for this kind of exercise. So I run this, and hopefully it should be all right. Yep, it's all done. Okay, so now, if I don't remember the find module, is it dash repository? It is called, we said, PSD. And the credential, I'm going to reuse the actual ones I already got. So if I run this command, you see that I can find on my repository called PSD, I can find my library with versioning and stuff. Okay, this could be a set of internal libraries developed over the years that you can control the distribution with. Once this is done, you install the module. I mean, I should not tell you this because you are PowerShell power users, so you should know that. But the name is get timestamp, and the credential again is always the same. That's because this is an authenticated feed, so you don't have anonymous access, right? Oh yeah, the scope. Should be good. It is good. So now if I run get timestamp, it works. And this has nothing to do with Azure DevOps, except for the fact that you're treating your own internal library as an artifact that you're building, testing, because you can run pest over there, and then deploying like you would with a web application or a Windows application or anything. Now, I did it in a very simple way, everything inside the build definition, but you could actually build your package. Oops. You can actually build your package and then create a release pipeline for your library, which is what I didn't show you before. So you build it, you get the package, right? You get the Nugget package, but it's useless if it's not pushed to the artifact feed. Well, what you can do is to create a pipeline with multiple stages, approvals, and the likes, and then you would say, okay, in this pipeline, what I would do is to, of course, use a certain version of Nugget that I need to use, and then push it to my feed, to my target feed. Now, this is inside the organization, inside the account, inside the collection, so you get a nice drop-down list of feeds, okay? But it could be an external Nugget server. It could be even public Nugget, right? So you can do it easily. And the best thing about it is that it's completely automated. So once it's set up, you're not going to touch it anymore. You can focus on actually writing your libraries and making them as good as they should be. All right? I mean, to me, it's a very quick introduction to the concept of CI/CD pipeline. But the fact that I saw in the past that people are stopped from using the same concept to PowerShell scripts just didn't make sense to me. I mean, it's still code, so you can't leverage on the same. Let's recap a little bit so you can quickly have lunch and beat the queue. You need to extract maximum value from the out-of-the-box task, and that's fairly straightforward to do. Then you can integrate your scripts with pipelines, like if they are out-of-the-box tools, in several ways. You can pack multiple scripts together with a task group, or you can actually create a custom task. It depends. It's up to you. And then, once you're done, you can control the consumption of both. And you can even reuse the same CI/CD concepts to your custom libraries. So even if you're not targeting a build server, you're not targeting some target environments, but you just want to share internally within the company your custom libraries, you can easily do it with a Nugget feed. And so you can have exactly the same process as you would with application code. Any other question? Okay, yeah. I thought there would have been none because there's lunch out there. But
So for the authenticated feed, is there any other way you can do it, for example, using like Azure AD credentials or something? Because having to give that, even to other technical people, it's a royal pain and potentially a security vulnerability.
of course, as I said, I didn't do it by the best practices, but it just worked. In Azure DevOps, you can, well, your identities live within Azure AD. If you're using a Microsoft account or custom accounts, either way, they live within there. So you can actually have a better authentication process and a better flow of authentication.
So you can use Azure AD authentication on a per-user basis to auth against
yeah, absolutely. I mean, again, this is a very simple example, but if you go into the artifacts section in the feed, you connect to your feed, and you can actually use an API key, which is a personal access token. Personal access tokens are unique for the account. And like you saw, I used one, which is an alphanumeric string. And so you don't even have credentials over there. You only have the token. Once you add via Nugget, you can add the repository with the personal access token. You are done. You're not going to touch it anymore. Okay. And here, should be, if I'm not wrong, in the settings, yeah. You can control who sees what, okay? So in this case, of course, I'm the owner and I have some set of contributors, okay? But I can have a good, well-structured ACL in place to make sure that you're prevented from pushing new versions, for example, when instead I can, stuff like that.
Thank you.
Cheers.
Right. So, what's the? Can you hear me?
Yeah, absolutely.
What's the interplay between the libraries that you build, the PowerShell libraries, and the custom tasks? Can you use those inside of your tasks? How does that work? Can you, when you create a task, the thing that you did initially,
Yeah.
can I then do a kind of module import when the task is run, and then run the function I made within that task? Does that make any sense? Because there are two different things that you showed us, right? One is the PowerShell library.
That's
one
correct.
Is the task.
Yes,
Okay.
that's correct. So last thing I've shown, PowerShell libraries, which has nothing to do with Azure DevOps except for the pipeline process. Okay, so it's just about reusing your existing libraries in a general context within an organization. Instead, about the pipelines, you can either encapsulate a set of scripts together with a task group. Okay, so instead of having 3 or 4 scripts all together, you just have one, and then you can pass all the execution variables and the conditions. Or you can create an actual custom task, which is going to be this set of 4 scripts or more or different, depending on the situation, which is then going to be used in a different manner. Because the task group is just internal, okay? So you create it, you reuse it internally, but that's it. The custom task could also be external. You can publish it on the marketplace. So I can go there and see your task and say, okay, yeah, that might be interesting. I will download it, and it will work, regardless of where it's used. So that's the difference between the two mainly.
Okay, I think I get it.
If you want, I will be outside.
Yeah, we could have a chat.
We
yeah.
can also have some further looks at it. No problem.
Sure. Okay.
Any other question? Time for lunch. Thank you very much.